let us see the one problem on turbojet engine. Okay, see the problem. In a jet propulsion unit, air is drawn into the rotary compressor. At 15 degrees centigrade and 1.01 bar. So for this, you have to draw the figure. This is the figure. So in this, you see, this is similar to open cycle gas turbine cycle. Here, additionally, we are having the jet nozzle. We have a compressor, combustion chamber, turbine. Okay, but this is for turbojet engine. Here, actually, we have one more device, that is the diffuser. But in this problem, is not mentioned about the diffuser. Then no need to consider the diffuser part in the TS diagram. So you have to start from compressor only. Okay, if you given, you have to consider. If you not mentioned in the problem, no need to consider the diffuser, right? That's why you have to start from the compressor. Is given the initial pressure and temperature. That means is given the P1 and T1. P1 and T1. See, once you see the problem. A jet propulsion unit air is drawn into the rotary compressor at 15 degrees centigrade and 1.01 bar. Okay, that is T1 and P1 is given the T1 and P1, right? And delivered at 4.04 bar is given the delivery pressure. That means from the after compression it will be delivered to the combustion chamber. That means given the next pressure P2. Where P2 is the 4.04 bar. Okay. The isentropic efficiency of compression is 82%. Isentropic compression means is given the isentropic efficiency for the compression. That is eta C equal to 82%. Okay. And the compression is uncooled. After delivery, the air is heated at constant pressure. The air is heated at the constant pressure. That means P2 equal to P3. See the figure, constant pressure. Okay, here always pressure is constant in the combustion chamber, but temperature will be raised. Temperature will be raised from P2 to P3. That's why P2 P3 is just same. Similarly, P5 and P1 also actually same. But you will mention that is okay. We will see later. Okay. So P2 in P3. And also is given that, see the problem. After delivery, the air is heated at constant pressure until the temperature reaches 750 degrees centigrade. Okay, after delivery means from 2 to 3. Okay, it reaches to 750 degrees centigrade is given the T3 temperature. Is given T3. See, this is a T3. You can refer the figure also. So this is the T3 is given T3 value. So after delivery, that means from 2 to 3, it is reaches up to 3. Pressure is constant, but temperature is increased. Okay, is given that temperature. After then, the air then passes through a turbine unit which drives the compressor only. Indirectly given the condition that the turbine work is equal to compressor work. Okay, as you know, to run the compressor you need a turbine work. Okay, right, and has an efficiency of 78%. Here is talking about turbine. Okay, so that efficiency is equal to 78% is given the turbine efficiency 78%. Before passing through the nozzle, and expanding to a atmosphere. Okay, pressure of 1.01 bar. We mentioned that from the turbine, okay, after from the turbine, it is entered to the nozzle and expanding to atmospheric pressure of 1.01 bar. That means this is the 1.01 bar, and initial pressure is also a 1.01 bar. Indirectly, it is again expanded to so actually 1 to 2 in compression, 2 to 3 in combustion chamber. C indicates compressor, CC combustion chamber, T indicates compressor, sorry, turbine, and JN indicates jet nozzle. We mentioned that after 5 means from the jet nozzle, it is expanded to, that means from 4 to 5. 4 to 5 it is expanded means temperature will be dropped. Temperature will be dropped from 4 to 5. Okay. So that is again to 1.01 bar. 1.01 bar. That means is given the P5. P5 is nothing but P1. Right? Okay, we will see. All of you note down the data. Okay. Everyone should note down the data. Okay. With efficiency of 88%. See. Now he's talking about nozzle. Nozzle 78% before passing through the nozzle and expanding to atmospheric pressure of 1.01 bar with an efficiency of 88%. That means he's given the nozzle efficiency. Here he is talking about nozzle. So nozzle efficiency is 88%. Okay. Neglecting any mass increase due to the weight of the fuel. Okay. Assume that R and gamma are unchanged by combustion. Determine. Okay, that is all or not necessary. No need to. So let us go for one by one. Determine first one, power required to drive the compressor. So here we have to find out the compressor work. This first one, WC equal to question mark. Okay, compressor work. Next one, all of you note down the given data. So first one you have to find out the compressor work. Next one, you have to find out the air fuel ratio. The fuel has a calorific value of 42,000. Is given the calorific value 42,000. Note down the data. Next, so here you have to find out the air fuel ratio. That means AFR, MA by MF, MA by MF. You have to find out. Next, the pressure of the gases leaving the turbine. Pressure of the gases leaving the turbine. See, so here this is the turbine where 3 is the starting initial to the intake to the turbine, 4 is the exit. This is the entry, this is exit. That means exit of the turbine means condition 4. So you have to find out the exhaust pressure from the end of the turbine. That means okay, you will see. Okay, so you have to find out the P4. Pressure of the gas leaving the turbine. Entry is P3, exit is P4. Okay, we'll see. Next, the thrust per kg of air per second. You have to find out the thrust per kg. That means you have per 1 kg. Per second, kg per second. Okay, you have to find out thrust. Neglect any effect of the velocity of approach. Assume R equal to and gamma equal to. You also mentioned that they are not changed. So take direct values, gamma and R values, you know, right? So now let us see one by one. First of all, you have to find out the power required to drive the compressor. Follow out, Mara. Respond, please. Anyone respond?
Yes, sir.
Okay, thank you. So first of all, you have to find out the power required to drive the compressor. So as you know, let's go for compressor. Here, compressor is in between 1 and 2. The device is 1 and 2. So as you know, the compressor work is the basic formula MCP delta T, where F 1 kg. So MCP delta T means CP T2 dash minus T1. Note down the formula for compressor work. WC equal to, okay, Cp T2 dash minus T1. Note down. So first of all, you have to find out compressor work. So in that compressor work, okay, so you have to find out T1, T2 dash and Cp values. Okay, so in the data is already given the T1 value and also just only T1 value. So you don't know Cp and T2 dash. Okay, we will see. So for that, first of all, you have to find out the T2 dash and Cp. You know Cp formula, the relation between gamma and Cp and R is, okay, Cp equal to R into gamma by gamma minus 1. Okay, we have a formula gamma is equal to Cp by Cv, Cp by Cv. Okay, and Cp minus Cv is equal to R. So from the two formulae, you know, Cp minus Cv is equal to R and gamma is equal to Cp by Cv. So from the two formulae, the final formula is, this is a direct formula. Okay, to find out the Cp, R into gamma by gamma minus 1 is given R and gamma values directly. So you can substitute and you can find out the Cp value. This is 1.004. This is also a direct standard value. The Cp standard value is 1.004 kilojoule per kg Kelvin. Okay, Cp is okay. Still, you have to find out the T2 dash. Okay, what about T2 dash? So to find out the T2 dash, okay, so in the problem is given the compressor efficiency. So from the compressor efficiency, you can find out the T2 dash. But here still in the compressor efficiency, some unknowns are there. T2, we don't know, but you know T1. So still you have to find out the T2 to find out T2 dash. That's why you have to go for temperature pressure relation. See this here. So in this problem is given already P2 and P1 is already given the P2 value and P1 values. The P1 equal to 1.01 bar and P2 equal to 4.04 bar. So you know gamma value also, and also you know T1 also. T1 is equal to 88 Kelvin. You have to convert into Kelvins. Okay. So by using that, you can find out the T2 value, right? By using the relation, you can find out the T2 value. So once you get the T2 value, you have to substitute the T2 value in compressor efficiency. You know compressor efficiency is given the value. So in this equation, you have to substitute all the values. The only unknown is T2 dash. You will get that value. That is T2 dash. That is a 458.7 kelvins. Okay. So once you get T2 dash, just you have to substitute in the compressor work. Finally, you will get the compressor work. That is 171.38 kilowatts. Right. The first one is over. The next one, you have to find the air fuel ratio. Next, you have to find out the air fuel ratio. This problem is similar to open cycle gas turbine because here diffusion is not mentioned. So that's why the problem is similar to like that. See, so suppose this is the open cycle gas turbine, okay, where efficiency network and heat supplied, where MCP T2 dash minus T1 is the compressor work, MCP T3 minus T4 is the turbine work. Okay, and similarly, if you observe, see, if air fuel ratio is given or you related to air fuel ratio, okay, I already told you in the open cycle gas turbine, the relation is heat supplied by fuel is equal to heat taken by burn gases. Okay, that is MF into CV equal to MI plus MF into CP T3 minus T2 dash. Okay, here combustion chamber in between 3 and 2 here. Okay, so as you know, by given the mass of fuel after burning, it will gives the calories. That means MF into CV is nothing but heat supplied. Okay, it must be equal to heat developed in the combustion chamber. That is nothing but MA MF CP T3 minus T2 dash. That means both equations are equal, right? So from the two equations, okay, you can find out the required values. Remember this equation. Second one, you have to find out the air fuel ratio. So for that, you have to take the equation MF into CV equal to MA plus MF into Cp T3 minus T2 dash. Okay, yeah, it's applied is equal to heat produced in the combustion chamber. That's why MF into Cv is the heat supplied, and the same heat is supplied to the combustion chamber. Then you will get this equation, that is MCP delta T. Okay, so you can see here. See, so this is the figure where combustion chamber in between 3 and 2. Okay, 3 and 2. That's why MCP T3 minus T2. Okay, that is the equation. Right. Where Ma plus Mf is the mass of air plus fuel. So to produce the gas, you have to give both. That's why Ma plus Mf. Okay. So with Cv is 42,000 kilojoule per kg. So from this equation, okay, I'm taking the same equation here. Okay, I'm simplifying this one. సో ఏం చేస్తున్నానంటే ఇక్కడ ఎంఎఫ్సివిలో సిపి తీసుకొచ్చాను చూడండి. ఎంఎఫ్సివి అలా ఉంచేసాను ఇక్కడ యాజిటీస్గా. ఎంఎఫ్సివి అలా ఉంచేసి ఓకే సిపి T3 మైనస్ T2 డివైడ్ చేస్తున్నాను. ఓకే, నెక్స్ట్ ఎంఏ ప్లస్ ఎంఎఫ్లో ప్లస్ ఎంఎఫ్ అటు వెళ్తే ఏమవుతుంది, మైనస్ ఎంఎఫ్ అయింది. సో ఆ విధంగా దీన్ని సింప్లిఫై చేసుకున్నాను. ఓకే, ఇప్పుడు నాకు ఏమొస్తుంది, ఈక్వేషన్లో మారింది కదా, ఇక్కడ మళ్ళీ ఎంఎఫ్ కామన్గా ఉంది, ఇక్కడ ఎంఎఫ్ ఇక్కడ ఎంఎఫ్ ఉంది కాబట్టి ఎంఎఫ్ కామన్ తీసి ఇప్పుడు ఏమవుతుంది, ఇక్కడ 1 CV మైనస్ 1 వస్తుంది. సో ఎంఎఫ్ కామన్ తీసి ఏం చేస్తాను, ఇది తీసుకొచ్చాను, ఎంఏ బై ఎంఎఫ్ కనుక వచ్చాను. సో ఆ విధంగా ఎంఏ బై ఎంఎఫ్ అనేది ఏ విధంగా మారిందంటే ఈ విధంగా మారింది. ఓకే, సో అప్పుడు పైన సివి కింద సిపి T3 మైనస్ T2 డాష్ మైనస్ 1, ఎందుకంటే ఎంఎఫ్ కామన్ తీసాం కాబట్టి అలా వచ్చింది. సో ఈ ఎంఏ బై ఎంఎఫ్ అంటే ఏంటి, ఎయిర్ ఫిల్ రేషియో మనకు కావాల్సిన అదే కాబట్టి ఆ ఈక్వేషన్ అలా మార్చుకున్నాం. సో నవ్ ఇన్ దిస్ ఈక్వేషన్ యూ నో ద సివి వాల్యూ, దట్ ఈస్ 42,000 and CP we already find that value, and you know T3 value directly given in the problem, and T2 dash we already find it on C. You can see the data. So this is the T2 dash, and T3 is given in the problem. Anyone tell me what is the T3 value? See, 1023. Check there, 1023, right? That is T3 value. So next one, after substituting all the values, you will get the MA by MF, that is 73.1. Okay, this is a air fill ratio. Okay, we assume that where MA equal to mass of air per kg, of fuel. So this is the mass of air. Okay, per kg means per 1 kg of fuel. That means 73.1 indicates the air and 1 indicates the 1 kg of fuel. That is the air fill ratio, right? The next one, third one, you have to find out the pressure of the gases leaving the turbine. That means P4. I already told you. Okay, you have to find out the P4. So to find out the P4, you can use the pressure temperature relation. But in that equation, we don't know T4. So for that, to find out the T4 value, you must use the turbine efficiency. Because turbine efficiency is given in the given data, right? But to find out the T4, still you don't know T4 dash. So for that, we have to use the condition that is given in the problem. Already told you. Okay, actual turbine work is equal to actual compressor work, where turbine is in between 3 and 4 CP. Actually, it's a cross value. Okay, reverse వచ్చింది, ఇది compressor work, ఇది turbine work. Okay, so the turbine is in between 3 and 4. That's why CP T3 minus T4, and compressor is in between 2 and 1. MCP, where M 1 kg. CP T2 dash minus T1. CP get cancelled. Okay, the remaining is T2 dash minus T1 is equal to T3 minus T4 dash. So except T4 dash, you know all the values. That is unknown. So you can find out the T4 dash, right? Once you get the T4 dash, okay, you have to substitute in the turbine efficiency equation. Then you will get the turbine efficiency. So sorry, you'll get the T4 value. Using the turbine efficiency, we already find the T4 value. Now substitute in temperature pressure relation. Okay. So from that temperature pressure relation, we can find out P4 easily because we know P3 value also. You know P3, that is 10. Sorry, that is check the P3 value. How much? I think P3 value is the 4.04. Is given the condition constant pressure P2 is equal to P3. Okay, is given the P3 value also. So P4 is equal to that value 0.43 into 0.43 into 4.04. Then you get the P4 value, right? Okay. Still the last one, you have to find out the thrust per kg of air per second. Thrust per kg of air per second. So for that, as you know, thrust means the product of CL. This is the thrust formula actually. We already discussed in the terminology. Thrust is equal to MA into Vj minus Va. Vj minus Va. But here, the device is in between 5 and 4. The device is in between 5 and 4. See, the jet nozzle. So from the jet nozzle, okay, gases are expanded with high velocity. Okay, see the device. The device is in between 4 and 5. Okay, but compared to 5, that means 5 means V5. The V4 dash value is very less. I already told you in the last class derivation. Okay. Otherwise, I'm showing once. So actually, క్వశ్చన్లో డిఫ్యూజర్ ఇస్తే మనకి ఇమేజ్ ఎలా వస్తుందమ్మా 1 to 2 వచ్చి. సో ఒక డిఫ్యూజర్ మనకి కన్సిడర్ చేయలేదు, అసలు కండిషన్ అనేది మెన్షన్ చేయలేదు కాబట్టి సో మనం డైరెక్ట్గా ఇక్కడ నుంచి స్టార్ట్ అయ్యమాట. సో ఇమేజ్ ఎలా మారిందో మీకు చూపించాను ఆల్రెడీ. దీనిలో ద లాస్ట్ డివైజర్ అంటే 5 to 6, ఇక్కడ 5 to 6, కానీ మన లెక్క ప్రకారం 4 to 5 అవుతుంది. ఓకేనా, ఎందుకంటే అక్కడ డిఫ్యూజర్ ఇవ్వలేదు కాబట్టి 1 to 2 అనేది నెంబరింగ్ ఉండదు కాబట్టి లాస్ట్ 5, 6 బదులు 4, 5 వస్తుంది. సో మనం జెట్ నాజ్ టాపిక్ చెప్పినప్పుడు చెప్పాను. So this is the ideal equation, this is the actual equation, but in between 5 and 4, 5 and 6. I told you where V6 is the very very high compared to V5. That's why you are neglecting the V5. Okay. So the same equation will be then V5 is neglected. Okay. So the equation will be finally coming like this. So from this equation, the actual equation, we neglect the V5. The remaining is H5, H6 and V6. Okay. So the equation is like this. So from that equation, we want V6. You can write H5 minus H6 into 2. Root out అవుతుంది. See the V6 equation. See చెప్పాను ఆల్రెడీ మనం క్లాస్లో చెప్పుకున్నాం. సో ఇప్పుడు ఏంటి, ఈ హెచ్ కాస్త మన టీలో మార్చాలంటే ఏంటి, హెచ్ అంటే ఏంటి, సిపి డెల్టా టీ. హెచ్ అంటే సిపి డెల్టా టీ చెప్పాను క్లాస్లో కూడా. హెచ్ ఇది సిపి డెల్టా టీ కదా. సో అదే ఏమవుతుందంటే ఇక్కడ ఈక్వేషన్ కాస్త సో ఈ హెచ్ ప్లస్ ఏమొస్తుంది, సిపి T5 మైనస్ T6 డాష్గా మారుతుంది. సో ఇక్కడ ఈక్వేషన్ 5కి 6 కాబట్టి మనకి ఇలా వచ్చింది. సో మన ఈ ప్రాబ్లం ప్రకారం ఏంటి, ప్రాసెస్ 4 to 5 కాబట్టి మనకు ఆ ఫిగర్ అనేది మారుతుంది. మనం మళ్ళీ ప్రాబ్లంకి వెళ్ళిపోతాం జస్ట్. ఓకే, see our problem. See, okay, so from our problem here you have to find out the thrust means MA into Vj minus Va, where Vj means V5 and Va means V4, but as per our earlier discussion, V4 is neglected. That means the only remaining is V5, where mass is 1 kg. Mass is 1 kg. That means thrust is equal to what? Thrust is nothing but Vj or V5 dash. Vj or V5 dash. So just you have to find out the V5 or Vj. V5 or Vj. Okay. see, this is our earlier condition. H4 dash is equal to H5 plus V5 square by 2. Where V5 is equal to 2 into root of 2 into H4 dash minus H5. But H4 means you have to, in place of H4, you have to substitute temperatures. Which means Cp delta T. That's why this is the final equation. Okay, this is the final equation. So simply Cj, C indicates the V, C or V are both the same. So Vj or Cj or V5, V5 or Vj or Cj are same. This is the final equation. Root of 2Cp into T4 dash minus T5 dash. So our point is to find out Vj. Vj is nothing but here just a thrust velocity. Okay, you'll see. So here, but in this equation, you don't know T5 dash. You don't know T5 dash. So that's why for that we have to use the nozzle efficiency. You have to use the nozzle efficiency. But still in the nozzle efficiency, you don't know T5. You don't know T5. So further you have to use the temperature pressure relation, where P4 is equal to where P4 I already find it, where P5 is equal to P1. Okay. So from that condition, from that relation, we get the T5 value. Got it? Once you get the T5 value, you can substitute in the nozzle efficiency, because nozzle efficiency is directly given in the problem. You know all the values except T5 dash. That is unknown. That is the required value. Okay. So once you get the T5 dash, you have to substitute the same value in this equation. Then you get automatically Cj. Cj means Vj. Vj means V5 dash. Okay. As per our condition, as Cj or Vj. So this is the test formula I already told you. Ma into Vj minus Va. This is from terminology. Okay. But Va or V4 is neglected. So it's still Ma into V5. So here Ma, here Vj or V5 value in 465.5 meter per second. That is the velocity. But we want thrust. Thrust means the units must be newtons. So here where Ma is equal to per kg per second. Kg per second. So velocity is meter per second. This is kg per second. So kg per second and meter per second. This is the mass per second. This is the meter velocity meter per second. So kg meter per second square is nothing but Newton. Kg meter per second is nothing but Newton. This is the thrust value. This is the final value. This means only Cj. Cj multiplied by just 1 kg per second. So you can see the problems. Is asking the last one is just find out the thrust per kg of air per second. That's where you find it. Okay. That's where you find it that value. Okay. Any doubts? You can ask.